Hi teachers. Today our groups will present about Docker and Anne will present the first one, introduction to Docker. So what is the define Docker? It's a platform of building, shipping, and running application in containers, and a container is a standard unit of software that the package up the code and is dependent, so the application run quickly and reliability from one computing environment to another. And Docker is a tool that is used to automate the development of application in lightweight containers, so that the application can work efficiently in different environments in isolation. And the key features of Docker including containerization, image-based deployment, portability, isolation, efficiency, and Docker can be used for application development and testing, microservice and architecture, and now it's become the essential tool for developer with a powerful and flexible platform of building, shipping, and running modern web application. So let's talk about the first feature of the Docker is consistency and portability. It includes a consistent environment that the Docker ensure the application are run in a consistent environment regardless of the underlying infrastructure, and this eliminates the this work on my machine problem and make it easier to collaborate and deploy application. And the second one is efficiency and resource utilization. Uh, and the third, automation and DevOps. And number four is microservice and architecture. Uh, Docker will well suited for building microservice and architectures where applications are broken down into smaller independent services. Each service can be packaged and deployed in its own container, making it easier to scale, update, and manage. In the isolation, Docker provides the isolation between microservices, preventing conflicts and improving fault tolerance. And number five is cloud native application. Cloud agnostic Docker container can be easily deployed on various cloud platforms, making them ideal for building cloud native applications. Scalability, the Docker portability and efficiency make it easy to scale application horizontally to meet demand. So the key concept of the containers in the Docker container is very important. It's like a self-contained package that runs an application and its all dependencies such as libraries, framework together. This package can be shipped and run on a machine that has Docker installed, regardless the operating system. For example, imagine you have a web application that requires Python and specific libraries. You can create a Docker image that includes Python and the necessary libraries. When you run this image, it will create a container where your web application can run. The next one is image. You can imagine that the image is bigger than the container. It's very essentially template for blueprints and container. They encapsulate the application code, libraries, and dependencies required to run the application. Think of them as a pre-configured environment that can be used to create multiple containers. And the last one, the Docker file, is a text document that contains a series of instructions commands used to build a Docker image. It defines the base image environment, variable dependencies, and command that will be executed when the image is built. The key component of a Docker file is the base image, the specific in the initial image that will be used as the foundation for new image. Instruction various instructions are used to build the image, such as from the specify to specify the image, run command to execute command in the image, the copy command used to copy the file from the host machine to the container, and the add copies file from the host machine to the container with the automatic tar extraction. The command work dir set the working directory within the container, export to export port from the container, and env is set the environment variables. The cmd specify the default command to run when the container starts. The entry point is specific the memory process to run the container. Additionally, there's two more important concepts of the Docker, like Docker Compose is a tool that allows you to define and run multi-container in Docker application. It uses the YAML file to specify the service and their dependencies. It makes it easier to manage and scale the complex application. And the last one is container orchestration. Container orchestration refers to automate the management of multiple containers. It involves tasks like the container deployment, automatically deploy container based on the defined configuration, the scaling, automatically scaling the container up or down is based on the demand of predefined rules, scheduling, assigning containers to specific node or host in a cluster, health monitoring the health of container and restarting failed one, service discovery, automatically discovering and registering service within a cluster. So now I have an example demo about the Docker file and the container show the image.
Continue with theoretical survey. Docker architecture. Docker is a clean server architecture. The Docker clean cut to the Docker daemon, which does the heavy lifting of building, running, and distributing your Docker container. The Docker clean and daemon can run on the some system, or you can connect a Docker client to a remote Docker daemon. The Docker client and daemon communicate within a REST API over UNIX socket or a network interface. Docker underlying technology. Docker is written in the Go programming language and that advantage us survival future of the Linux can to deliver its functionality. Docker uses technology called namely to provide the isolate workspace on the container. When you run a container, Docker create a set of namespace for that container. Docker leverage several underlying technology to provide its functionality. With namespace isolate container run at order and run the host system, create space namespace for process, networking, PID, mobile and user ID with control group limit the result CPU memory input output that the container can consume, provide file range control over result application with union file system combine multiple layer based on the snapshot into a scene view for the container efficiently manage email layer and chain. Net Docker simply the development and development not yet would cover the benefit and would containerization offers several advantages for not yet developed consilient developed environment. With Docker develop can define and share a consilient developed environment across data. Everyone work with the same set of event and configuration, eliminating the notorious "It's work on my machine" problem. With dependency management, Docker enables easy management of application dependent by encapsulating on dependent within the container. You can avoid conflict between the different versions of library and packet, ensuring a smooth and error-free runtime environment with isolation and reproducibility. Container provide isolation between applications, preventing one application from interfering with another. Docker containers are also highly reduced, allow you to rewrite the exact runtime environment wherever needed. With portability, Docker containers are highly portable and can run on any platform that support Docker. This portability makes it easy to deploy applications across different Last chapter provide good scalability. Docker simplifies scaling application by enable the deployment of multiple instead of container within the sub-application. With Docker object function tool like Docker Swarm or Kubernetes, you can easily scale your Node.js application horizontally to handle inquiry traffic and demand and continue silent on containerization. Uh, with scalability without management and ensuring that container have network without CPU memory network to perform optimally can be challenging, especially in dynamic environment. Horizontal scaling, while the map horizontal scaling easier, it can still require careful configuration and management to avoid performance bottleneck. Isolation, security, and right, ensuring that continue are very isolate from each other and the host system is crucial to prevent security threat with the government of automation configuration management. Uh, with debugging and troubleshooting with containing block and debugging challenge with network management, containing networking, configuring and management network for container can be complete, especially in large deployment with multiple network and survive and network performance, ensuring that container have element network result and performance can be challenged, especially environment with high network traffic. And final is email management. Email child can impact deployment time and result. Usha optimizing email child is important for excellent continuation with email security, ensuring that my email and dependent are up to date and secure are critical to prevent vulnerability.
So I have a simple example of the Docker. As you can see that we have the Docker file in the project. How this works? The first one is the command prompt. This used to define the image for the project Docker, and the second one is to work R is set the working directory for the app project, and this line of code is present the copy of the backend code to run in example in run in another computer, and the command run npm install expect mongoose is install in dependencies from the database. The export command is to illustrate the port for the project, and to run the app we use the command simply not app.js, and go to the we have a docker compose .yml. This lines of code to illustrate the port for the front end, such as HTML or Angular or something, and this is the setting up for the back end with the port 4000, and the environment for the database we use that in the MongoDB, and this line of code to call the port from the database, and this is another sample of the Docker with the completely project. We have the Docker file and the Docker file itself and the Docker compose. To run the Docker, we have the Docker build, Docker up, and to start the Docker project we use the command Docker down. Now we move to the next part of presentation.
So we just discussed how to demo the Docker. So now we're gonna move on to the presentation at chapter 5, resolve and discussion. Let me share the Docker. So the project outcomes to Dockerization, we are able to successfully containerize a modern web application, which made it easier to run across different environments without issues. By packaging the application and its dependencies into the Docker container, we achieve consistency across development, testing, and production, ensuring the application behaves the same in every scenarios. So there are 3 key results: that is consistent environment, simplified development, and better cooperation. The consistent environment Docker container allows us to maintain a uniform environment across all stages of the project, reducing problems related to the environment differences. And the simplified development is developing the application become more streamlined, cutting down on setup times and reducing the potential errors. Better collaboration means that team members benefit from working in the same environments, leading to fewer problems related to differences in development setup. So we got Docker results have 4 things we can discuss. The first thing is performance. The containerized version of the application performs similarly to its non-containerized version, with only minor performance impacts, mainly during startup. Docker lightweight design means the application could run efficiently without adding significant overhead. Like the CPU and the memorized management, Docker gave us more control over resource usage, allow us to fine-tune CPU and memory limits, ensuring the application ran efficiently. Optimization, we use techniques like multi-state build and reducing unnecessary dependencies to decrease the container size and improve startup time. Next will be scalability. That means Docker makes scaling the application straightforward using orchestration tools like Docker Compose or Kubernetes. We could quickly add more containers to handle increased traffic and load balancing. Kubernetes helps automate scaling and load balancing, which ensure the system could handle surge and in traffic without any downtime or degradation in performance. The next thing will be reliability, and Docker isolation of container make the application more reliable, and each container could be restarted independently if it failed without affecting the rest of the system. Minimize downtime. We use Kubernetes to implement rolling updates, which ensure continuous service during update without disrupting users. And the last thing we're gonna discuss is the challenge and the solution. We got networking. Managing communication between containers was initially tricky, but the Docker networking capabilities allow us to set up secure communication between containers. Uh, Persistent data. Since containers are stateless, handling persistent data was challenging. We resolved this by using Docker volumes and a storage system to ensure that data are persistent. We got large image size, like early on our container image was too large, leading to slower development. To fix this, we optimize our Docker files by using smaller base image like OPIs and remove unnecessary files. The last thing is securities. We address securities concerned by implementing Docker security features like namespace and capabilities, and consistently updating our base image to protect against vulnerabilities. The last thing we're gonna go to is conclusion. So conclusion, we have three key takeaways that we need to remember. The first thing is the environment consistency. The Docker proved invaluable in maintaining consistent environment across development, testing, and production, reducing issues to often arise from different setup. The second thing is the speed and efficiencies. Dockerization significantly improves the development process by reducing setup times and automating key tasks with orchestration like tools like Kubernetes. And the last thing is scalability and stability. Docker is of scaling and robust handling of traffic surge that make it ideal for ensuring the application scalability and reliability is in production environments. So we have a Docker that impacts on web application. Docker also enhance the development and deployment of modern web application by simplified environment setup, like making the development process much more predictable. It fits seamlessly into CI and CD pipelines, allowing developers to roll out updates with less risk and downtime. It also supports modern architecture like microservice where different parts of application can be containerized and managed independently. So overall, we have know what Docker is, and the Docker has proven that to be a powerful tool for improving portability, scalability, and reliability for web application, making it a critical part of modern software development practice. And thank you guys for very much for listening to our presentation, and that's it.